Hello. In the earlier session, we have understood what is an instantaneous center, what are relative instantaneous centers, as well as we have understood the Ehrenholtz-Kennedy theorem. Now, what is the Kennedy theorem is stating that when three rigid bodies are in relative motion to each other, then the instantaneous centers, three instantaneous centers will be collinear. Now, today we are going to do the velocity analysis by using the instantaneous center. So this is the instantaneous center method by which we are going to do the velocity analysis. So let us take an example, and with a generalized way we are going to find out the solution for this problem, how we can determine the velocities with the help of the instantaneous centers. So let us consider a 4-bar chain, simple 4-bar chain, say so this is how, let us say this is a 4-bar chain given to us, and this is the configuration diagram what we are drawing with whatever specific dimensions are given to us. So this is link number 1, let us say this is link number 2, this is link number 3, and this is link number 4, and say given that we are provided with, say, let us say the angular velocity of link number 2, which is omega 2. So maybe say this is turning in this fashion, and this is the input link, and the velocity or angular velocity of this link is given to us, and we have to determine, or we have to find, let us say, the velocity of link number 3 and the link number 4. So these are the two unknowns which we have to determine, the angular velocity of link number 3 and angular velocity of link number 4. Now, first of all, we will have to then, as we are finding or doing the analysis with the help of instantaneous centers, then we will have to determine the number of instantaneous centers first. So for that, we know that the number of instantaneous centers is given by n into n minus 1 by 2. So here it is a 4-bar mechanism. So the n is 4. So 4 into 4 minus 1 by 2. So it will come out to be as 6. So number of instantaneous centers for this mechanism is 6. Now the next thing will be to locate those instantaneous centers. Now, if we see, there are 3 types of instantaneous centers. One, they are called as the fixed instantaneous centers. Number 2, they are called as the permanent instantaneous centers. And number 3, they are nor fixed nor permanent. So these are the 3 types of instantaneous centers which are existing. Now the first 2 types, the fixed and the permanent, they are found out or determined by inspection. So if we inspect the given mechanism, we can locate those instantaneous centers, and these which are nor fixed nor permanent, that we have to locate with the help of certain construction, or at that time we will invoke or use the Ehrenholtz-Kennedy theorem to determine the rest. Now, first thing first, then I'll have to first understand which are the instantaneous centers. Now, for that we can use a simple explanation with the help of which we can determine. So we have seen that the number of instantaneous centers is coming out to be, or number of instantaneous centers is coming out to be 6. So this we have seen. Now to locate those, so we can do a very simple exercise, right? It's a kind of a, so the number of links is 4. So I'll just write 1, 2, 3 and 4. So we have seen while determining the instantaneous center, at a time we are considering two bodies. So there will be an instantaneous center with respect to 1 and 2, then instantaneous center between 1 and 3, and instantaneous center between 1 and 4. So instantaneous, and we will number them as say 1 2, 1 3, 1 4. Now 2 with 3 and 2 with 4. So 2 3 and 2 4. These are the instantaneous centers. Then 3 4. Now 3 2 is already existing. 2 or 3, 3 or 2, it is one and the same thing. 3 1, that is also existing. Then 4 3, so 3 4. 4 2 is 2 4 or 4 3. So the number of instantaneous centers are coming out to be 6, and these many will be the instantaneous centers. Now we have to locate them. Now by inspection, if we see, there are 4 joints. So certainly these joints will be instantaneous centers. Now if you see, so let us name them. So let us name this joint as A, this as B, this is C, and this is D. So then joint between, so this is one of the coincident points. If you remember the relative instantaneous center. What is a relative instantaneous center? So if there are two bodies, then there exists a point in the body 2 whose instantaneous velocity is 0, and it is a coincident point of body 1. So if we see, this joint is such a point which is coincident, and at this time this body 2 is rotating about A. So that means, and this is a coincident point of 1. So this becomes one of the instantaneous centers. And if you see, this point is point on the frame. So frame is fixed. So absolute motion of A is 0. So such joints or such instantaneous centers come under the category of fixed instantaneous centers. Now if you see B, now B becomes a coincident point for 2 and 3. But when this link turns, B is going to shift. But the joint between B 2 and 3, that is not going to change. So the joint is permanent, right? Or the instantaneous center of rotation is permanent, but it is not fixed. It is moving. It will be having its own path, whatever it is. So this joint B and joint C, they come under the category of permanent instantaneous centers. So now if we see, this is instantaneous between center 1 and 2 is A. So this we name as I12. B is, so this joint, if you see, it is a joint between 2 and 3. So this point is as well instantaneous centers, center I23. So as well we are going to mark them on this chart. So 1 2 and 2 3 is done. Then joint between 3 and 4. So joint C, this is between 3 and 4. So I 3 4, and this is D, is again joint between 1 and 4. So this is I 1 4. So 3 4 1 4. 3 4 is done. 1 4 is done. So which are the two we have to determine? The instantaneous centers 1 3 and 2 4. Now for this, now we will have to take help of Ehrenholtz-Kennedy theorem. And what does Ehrenholtz-Kennedy theorem states? Now it is stating that when three rigid bodies are in relative motion, then their instantaneous centers will be collinear, right? So let us take the first situation, say wherein I am going to consider three rigid bodies out of this mechanism. Say the body or link number So let us consider links, say 1, 4 and 3. So we consider links 1, 4 and 3. So when we consider links 1, 4 and 3, what are the instantaneous centers? We can get 3 instantaneous considering 3 links, then the pairing between 1 and 4, 1 and 3 and 4 and 3. Right? So the instantaneous centers here I will get 1, 4, 1, 3 and 1, 4, 1, 3 and 4, 3, and according to Ehrenholtz-Kennedy theorem, these 3 will be collinear. Right? So let us go for then in our configuration diagram. So it is saying that 1, 4. So this is 1, 4. 4, 3 or 3, 4 will be the same. So out of which this 1, 4 and 4, 3 or 3, 4 is there. We have already located. So that means these two instantaneous centers must lie on the, these are collinear. That means if I join 1, 4 with 3, 4, so this line, if I extend this, so maybe this side or wherever, right? So on this line, definitely this instantaneous 1, 3 must be existing, or as if I can say this is locus of 1, 3, I 1, 3. Then we consider a second combination. Let us say the 3 rigid bodies. Now I consider for the second consideration. So let us consider that considering links which 1, 2 and 3. Considering links 1, 2 and 3. So this will also give 3 instantaneous centers. So 1 and 2, 1 and 3 and 2 and 3. So the links will or the instantaneous centers will be 1, 2, that is I 1, 2, I 1, 3 and I 2, 3. Out of which again instantaneous I 1, 2 we have already located, I 2, 3 we have located, I 3, 1, 3 is not determined yet, but these 3 instantaneous centers will again be definitely collinear. So if I join 1, 2 and 2, 3, so I 1, 2, I 2, 3, when I join and I extend that line, so this line is also locus for the instantaneous I 1, 3. So if you see this line is intersecting here, that means this point we have located this as I 1, 3. So that is how we have located I 1, 3. Now what is remaining is 2, 4. So now I consider the 3 bodies which are in relative motion to each other. So considering links, now what I want, 2, 4, so 4 has to be included. So 1, 2 and 4. So we consider the links 1, 2 and 4. So the instantaneous centers what we will get is 1, 2, 1, 4 and 2, 4. So the instantaneous centers 1, 2, 1, 4 and 2, 4. Again out of which 1, 2 and 1, 4 are already determined. So 1, 2 and 1, 4 they are already determined. So if I join these 2 points, that means 1, 2 and 1, 4, that is A and B. If I join it and I extend, so somewhere on this line I will get the instantaneous center 2, 4. Fine. So now I'll go for the fourth consideration. So we go for the fourth consideration. So considering the links, now 2, 4 must be included because we want 2, 4. So it will be 2, 3 and 4. So we consider the links 2, 3 and 4. So there, for these three bodies, which will be the instantaneous centers? 2, 3, 2, 4 and 3, 4. So we get the instantaneous centers will be 2, 3, 2, 4 and 3, 4. So these three instantaneous centers, they will be collinear. Right? Out of which again 2, 3 and 3, 4 we have already located. 2, 3 and 3, 4 we have already located. That means joint B and joint C. So now if I join this line and extend this line must be the locus for the link 2, 4. So we extend it and say it intersects here. So at this location we get the instantaneous center I2, we get I2, 4. So that is how we have now located all the 6 instantaneous centers, and now we will see how we can use these instantaneous centers to do the velocity analysis. So we have seen and we have located all the 6 instantaneous centers, and now we are going to use those instantaneous centers to determine the omega 3, that is angular velocity of link 3 and the angular velocity of the link 4. Now let us see here, when this is rotating clockwise, what will be velocity of B? Now velocity of B, or the instantaneous velocity of B with respect to A, I can write it with respect to A, or when it is absolute, definitely with respect to fixed, so I can simply write velocity of B. So the instantaneous velocity of B will be omega 2 into the link length AB, or I can say I12, I23, right? So that distance we can get it from the configuration diagram. We know this length. So maybe right now I write it this as length AB, right? So this is now known to us. Now if this body is such, this body is, so if we see the velocity vector, so it will be perpendicular to the link AB, so, and it is turning in this direction, so I can say this is velocity of B with respect to A. Now if this is so, and these are instantaneous centers, that means that in this instant B is having motion in, when we are considering B on link AB. Now this B or I center 2, 3 is a common point for 2 and 3. So now when we are considering B to be on link 2, then the velocity will be this, as we know this value, that means B is known to us. Velocity of B is known to us. Now when it is the B is the same point, though it is on link number 3, its velocity is not going to change, it will be the same velocity. So now when I consider B on the link 3, and at this instant this link 3 is rotating about the instantaneous center I13. So I can say that very well the velocity of B is not going to change. Then as well, velocity of B is equal to, it will be omega 3, and what will be its distance of C? When this is perpendicular to this is as well perpendicular to this one. So as if B is as well rotating about I3. So that means it will be omega 3 into B, this length, B I13. So from the configuration diagram, we can very well measure this distance BI3. If I put this value, and this we have just now determined with the help of the equation number 1. So we can very well determine omega 3 as velocity of B upon this distance B I13. So thus the angular velocity of 3 is determined. Now when this is turning in this direction, the velocity vector is having this direction, so that means as if then this is turning in this fashion, so as if, so this is counterclockwise, so this is turning, so we have determined the omega 3 directly. Now similarly, when I have to determine the angular velocity of link number 4, so I have to work out angular velocity for link number 4. So for this, then I will be taking help of the instantaneous center I24. Now when this is rotating as if this entire link is as well rotating about I124, or relatively I2124 is rotating about link 24. So in that case, I can say that the velocity, so this was the first we have determined, and now we have to determine omega 4. So I can say I24, or sorry, the velocity, instantaneous velocity of I24, this will be then omega 2, which is known again, into the radial distance for this is I12, I24. So we have determined, so this is known to us, omega 2, and these two values, this distance I12 and I24, I can get it from the configuration diagram, I can measure it, so I place that value, so I can determine, so this, let us call this as equation number 2. So that is how I can determine velocity, instantaneous velocity of the instantaneous center I24. So now I can consider, now when we have considered these three bodies, so as if this is also rotating about, see, when these three are collinear, that means this is as well right now rotating about the link number 4. Again, when it is the same point, then the instantaneous velocity of I24 is not going to change, it is going to be the same, it is one and the same point. So very well, then again we can say as well, velocity of I24 will be omega 4 into, then this is its distance from the link number 4. So I24, I14. So I24, I14. So again, I24 we have already determined in the equation number 2. So we can say that omega 4 is velocity of I24 upon I24 distance I24 I14 from the configuration diagram, and thus we can determine the omega 4 as well. So that is how, now this is the frame, its absolute velocity is going to be 0, so thus we can determine, this was given to us, so we have determined the angular velocity of link number 3 as well as angular velocity of link number 4 with the help of instantaneous center method. Right? Now say for example there is some other point which is given to us. For example, say there is some point P on the link number 3 is given to me, and I have to determine the angular velocity or the velocity of this. So I can simply join this point. So Pi3. So I can determine velocity of P, absolute velocity of P, omega 3. It is on which link? It is on the link 3. So it should be omega 3 into the distance Pi13. So that is how any other point whose velocity is to be determined, then I can determine those velocities once these velocities are determined. So that is how we are taking help, or we are using taking help of the Kennedy theorem, and we are using the instantaneous centers to determine the angular velocities or unknown velocities for the given mechanism. So that is what we have seen. So we have understood what is an instantaneous center, what are relative instantaneous centers, and how we can use those instantaneous centers to determine or do the velocity analysis for a given mechanism. So this is all for this session.